I am Nadav. I'm a professor in NTNU in Trondheim, Norway. I'm also the coordinator of this EU project, iCULTURE. The idea with the project originally was to use the waste of seaweed after the companies in Europe extract valuable product from the seaweed, alginate and other product. But they are left with a lot of leftovers, waste they call it, and they had no strategy how to use it besides dump it in the landfills. And since I'm a scientist that work with a large laboratory that work on fermentation, of bacterial fermentation, the idea was to develop a process, including bacteria, that can consume this waste seaweed and produce very valuable molecules for the society, pharmaceutical molecules, vitamins, and molecules that are important for food and feed. So this is how iCULTURE was born. The workflow of the project is going to be relatively simple. We are creating an engineering bacteria that then can consume the products or what the seaweed, the waste of the seaweed is composed of. Following that, we are developing a process, automated process, supervised by AI units and software that actually monitor every stage in the process of the fermentation to be sure that all the biomass, the waste leftovers of the seaweed, are going to be converted to these valuable products. But that's not enough, because in addition to this utilizing or using the seaweed waste, we also want to protect the seaweed in the seas. So big part, many groups in the project are dedicated to understand what are the weaknesses of the seaweed, how to harvest, when to harvest, how to prevent over-harvesting, so we will not get to a situation when we deplete the sea from seaweed. So together, preservation and utilization are two parts of the iCULTURE, and going to give us the, we hope, the great result of using waste of seaweed to produce pharmaceutical molecules. There are many challenges in iCULTURE. The biggest challenges I can now raise is, for the first, bacteria was evolved during billions of years to consume glucose-based sugars. Glucose-based sugars, you know them as sugar cane, the sources are sugar beet, but the seaweed don't contain almost none of these sugars. They contain other types of sugars. Things like called xylose, arabinose. They are sugar molecules, but that regular metabolism of humans or bacteria don't actually evolve to consume. This is one challenge, because it means that if I give it this seaweed waste to our bacteria, to a regular bacteria, industrial bacteria, it will not consume it. It will actually die. So one of the challenges is how to engineer the bacteria so it will be able to consume this irregular sugar in the seaweed. Another challenge is how actually to create a process that is so profitable that it will not create overfishing. Because imagine a case where we actually manage to produce to develop a process that consumes and produce very high value from a waste. So the profits can be so high that people will be eager to harvest as much seaweed as they can. So one of the challenges is to create a kind of a tool, a model, and a guideline how to prevent over-harvesting, when to harvest, how to harvest, how much to harvest. So we will preserve not just the seaweed, but all the life form that surrounds it, including fish and crabs, etc.